Okay, hi Year 11. What we're looking at today is area of a triangle and the sine rule and cosine rule. This is all stuff you've done in Year 10. So let's have a look at it. First of all, area of a triangle is a half AB sine C. And as you know previously, back in Year 7, you also would have done area equals a half times the base times the height, right? Or some of you might know it as base times height divided by 2. Both the same thing. Okay, so this is what you did in Year 10, area of a triangle using trigonometry. Now, A and B are the two given sides, and angle C is the side in between the two given sides. So, for example, here we have A and B, and C has to be the angle between the two given sides. All right? Now, let's have a look at a proof of this. Rightio. So, first of all, what do we know? We know that for any triangle, area equals a half times the base times the height. Okay. So let's start off with something involving the base. Okay. So we know that, let's just change colors here. We know that sine C in this triangle over here, so this is the triangle I'm looking at. Sine C using SOHCAHTOA is opposite divided by hypotenuse, which is H over A. And that gives me H equals A sine C. Okay, now in this triangle, the base is this length here. We're going to call it AC. Okay. In actual fact, we're going to call it B. So B is the whole base of this triangle. So if we look at our Year 7 formula, area equals a half times the base, B for base, times by the height. Well, here's the height. Height is just A sine C, isn't it? Okay, so we can then just rearrange that to have half A, B sine C. So that's the proof for the area of a triangle using trigonometry. Okay, so let's have a look at a question. So we've got to calculate the area of the triangle below correct to one decimal place. Now we need two given sides, and actually we've got three given sides, and we need the angle between the two given sides. So this is my angle between the two given sides, and so the two sides that we're looking at will be this side all the way up here. So remember, when you're doing these questions, you've got to choose two sides and the angle between them. Okay, so that's this angle and the other two sides. Okay, write your formula down. Area equals a half AB sine C, which equals a half times 4.3 times 5.8 times sine 112 degrees, 34 minutes. Okay, so put that into your calculator. So you're going to have a half times 4.3 times 5.8 times sine of 112 degrees, 34 minutes, and you should get 11.5. It says one decimal place, we'll just go 11.5. So 11.5, and that's square meters. Okay, so you should use approximations when you're rounding. All right, let's try the next one. Now for this triangle, we can do the same thing. We're going to write down the formula. Area equals a half AB sine C. Something happened to these labels here, not sure. Half. Now remember, you need two sides. So this side here right, is what you're given. And this side here is what you're given as well. Okay, so you need two sides and the angle between them. Now, we don't need the angle between them yet, but we can work it out. 70 plus 71 is 141. Subtract that from 180, and you're going to get 39 degrees. Okay, so the area will be a half times 69 times 70 times sine of 39 degrees. Okay, so that equals 0.5 times 69 times 70 times sine of 39 degrees. Okay, so that's 1519.8. So one decimal place. Millimeters squared. Okay. All right, so that's area of a triangle. Now, let's look at the cosine rule. This is also something you did in year 10. Cosine rule says a squared equals b squared plus c squared minus 2bc cos a. B and C are the two given sides. Angle A is the angle between the two given sides and is called the included angle. Side A and angle A are always opposite each other. Okay, so that's what you would have learned in year 10. Now, don't get hung up on the labels here, A, B, and C. They could be any labels. They could be X, Y, and Z. You could even put C as your first letter. C squared equals A squared plus B squared minus 2AB cos C. Now, whichever formula you're going to be using, or whichever letters, you just have to remember that the side C, which is this one here, and angle C, which is this one here, are always opposite each other. Okay, so in the formula, side C, and that's little c there, and that's big C here, are always opposite each other. Okay. All right, so let's have a look at this. Now, there's two forms of the cosine rule, isn't there? There's this one here. That's for finding a unknown side. And then also there's this, we can rearrange the cosine rule here. And that's for finding an angle. Okay? So let's have a look at this question. Now, how do we know we're going to use the cosine rule? We use the cosine rule when there are three given sides and an angle involved in the question. So for the cosine rule, use three sides and one angle for the question. Okay. Now, let's have a look at this first question here. We have three sides, don't we? Yes, three sides. There's one, there's two. We've got to find the length of the third side. So the cosine rule involves three sides and one angle. Okay. So first thing to do is to write down the formula. A squared equals b squared plus c squared minus 2bc cos A. Okay. Next. Now, A is always unknown side, so that's going to be X for me and for you as well. B and C, well, that can be any sides you want, so I'm going to label this A, this is B, and this is C, but B and C can be swapped around. And obviously, this will be capital A here. Okay, so 5.6 squared plus 6.4 squared minus 2 times 5.6 times 6.4, and then cosine of the angle, which is 112 degrees, 32 minutes. Okay. Now let's put all of that into the calculator. So you're going to get 5.6 squared plus 6.4 squared minus 2 times 5.6 times 6.4 cosine 112 degrees, 32 minutes. equals. So you're going to get 99.78 and a whole lot of decimal places. Now we're actually going to leave that whole expression on the calculator. So I'm not going to write it all down. So 99.789. So now dot, dot, dot for all the other decimal places. Then you're going to square root both sides to get the x by itself. So square root both sides. Now x equals. So I'm going to press on the calculator square root, and then I'm going to press the answer button to enter the decimal that I just had, and that gives me 9.984. Okay, so on your screen, 9.9894, 9894, and it keeps going forever. Okay. Now, it does say to the nearest whole number. So then, after that, I'm going to write down my rounded answer. Okay, so x is approximately equal to 10 units in length. Okay. All right, next question. Now here we've got to find theta in degrees and minutes. So we're going to write down our formula first for finding an angle. Okay, so if you go back to page 1, finding an angle, cos A, here it is. This is the 1. So we're going to use this form of the cosine rule. All right, so cos A, b squared plus c squared minus a squared. Okay, so cosine of A equals b squared plus c squared minus a squared over 2bc. And remember, angle A and side A are opposite each other, okay? So on my diagram over here, I'm going to call this here angle A, and then the side opposite angle A is little a, lowercase a. Okay, the other two sides are B and C, doesn't matter which is B, which is C. All right, so cosine of theta equals 6 squared plus 5 squared minus 3 squared, and that's over 2 times 6 times 5. Okay, now if you put that fraction into your calculator, what do you get? Let's have a look. We're going to have 6 squared. I'm using the fraction button on the calculator. Minus 3 squared over 2 times 6 times 5. You'll get 13 on 15 exactly. So that does simplify to an exact number. And then what you're going to do to work out the angle is you're going to say, well, theta must be the inverse cosine of 13 on 15, which is equal to, so you're going to go shift cos or inverse cos, shift cos, which gives you the inverse cos, 13 over 15, close bracket, equals. Now you're going to get degrees and minutes there. So you should get 29.926 dot, 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 degrees. But if you press your degrees, minutes, seconds button, you'll get 29 degrees, 56 minutes to the nearest minute. 29 degrees, 56 minutes. Okay. So that was the cosine rule. And again, what did the cosine rule involve? It involved 3 sides, 1, 2, 3, and an angle. So cosine rule always involves 3 sides and an angle. Okay, let's have a look at the next question. Okay, so first thing I'll do again is just write down the formula. So cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Okay, so remember angle A and, well, the unknown side here, Actually, no, that's the wrong formula, isn't it? I just realised. We're finding a side here, not an angle. So that's the wrong formula. Okay, so it should be a squared equals b squared plus c squared minus 2bc cos a. Now remember, a is always the unknown side and capital A is the angle opposite that, okay? B and C are the other two sides. All right, so we're going to have k squared, so I'm not going to worry about the meters yet. K squared is equal to 8.4 squared plus 12.9 squared minus 2 times 8.4 times 12.9, little decimal point there, and cosine of 37 degrees. Okay, just fit it in there. Okay, so it gives me k squared equals, so put the whole thing into your calculator, 8.4 squared plus 12.9 squared minus 2 times 8.4 times 12.9 times cosine of 37. Okay, that gives you 63.88. And then you're going to square root both sides. Okay, square root both sides. Now leave that whole decimal in your calculator and just go square root. You should get just press square root answer. Okay, so what I do on the calculator is I press the square root button and then I press the answer button, and that uses the previous decimal, which is 63.88, etc., and it puts it inside the square root symbol. So just press square root answer, and that will give you k equals 7.993 ... and to one decimal place, that will be 8.0 and then meters. Okay, next question. Okay, the sine rule. Now, for the sine rule, this is the sine rule. There's two forms of the sine rule. We use this form if we're finding an angle, and we use this form if we're finding a side. And just remember that angle A is opposite side A. Okay, you can see that there with the arrow. Angle B is opposite side B, and so on. Okay. Now, we only use 2 of the 3 ratios at a time. So when you're using the sine rule, you only write down 1 equal sign. Okay, so you only use 2 bits of the formula. There's 3 bits, isn't there? There's 1, 2, 3 bits. So you only use 2 bits of the formula at a time. Now, what's different about the sine rule? It doesn't use three sides. It only uses 2 sides and 2 angles opposite those sides. Okay, so let's look at the first question. Got to find the length of x here. Now, we're finding a side, so we're going to use this form of the sine rule. A over sine A equals B over sine B. Okay, so it's going to give me, now x will be the unknown side. Now the angle opposite that is 43 degrees 20 minutes. So this will be sine 43 degrees 21 minutes. And the other side is 10.7 divided by, now the angle opposite that side is here. So I've got to use that angle for this side, sine 79 degrees 12 minutes. Okay, now to get the x by itself, I've got to get rid of the denominator here. So what I'm going to do is multiply both sides by sine 43 degrees 21 minutes. So over here I'm going to have sine 43 3 degrees, 21 minutes, and that's multiplication. Okay, so once you've done that, you can cancel this numerator with this denominator. And then you'll have x is equal to, now you can put that whole thing into our calculator, so 10.7 over sine 79 degrees, 12 minutes, multiplied by sine 43 degrees, 21 minutes, equals 7.47. Okay. Now to one decimal place, so you're going to get 7.47 dot 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 dot. Now to one decimal place, it'll be 7.5 centimeters. Okay, now you can pause the video if you want to try question number 2 by yourself. Okay, so again, I'll just write the sine rule down. I'm finding an unknown side here. Here it is. I've got to find that side. So I'm going to write down the sine rule again. A over sine A equals B over sine B. You only ever use 2 parts of the sine rule. And Y is my unknown side. The side opposite. Sorry, that's my bad there. The angle opposite that side is here. Now, what is that angle? I can work it out. What's 53 plus 24? It's going to be 77. Take that away from 180. That's 103. So this angle here is 103 degrees. So it'll be over sine 103 degrees equals 8 is my other side. And the angle opposite that side is 53 degrees. So sine 53 degrees. And now to get the y by itself, I'm going to times both sides by the denominator of the y. So multiply by sine 103 degrees on that side and multiply by sine. Okay, so that cancels with that. And then you get y is equal to, now put that whole thing into your calculator. So 8 over sine 53 degrees multiplied by sine 103 degrees equals. Okay, so you get 9.76. So to the nearest whole number, I'm going to round that to 10 units. Okay. All right, let's have a look at this one. We've got to find the value of theta in degrees of minutes. So we're finding an angle. Because we're finding an angle, we're going to be using this form of the sine rule. Sine A over A equals sine B over B. Okay, so theta is my unknown angle, so I'm going to put theta there for the A, and the side opposite that is 6.7. So that I put 6.7 here equals, now sine B, here's my other angle. So sine 86 degrees, 11 minutes, divided by, now the side opposite that is here. So divided by 8.3. All right, now to get the theta by itself, the first thing I've got to do is get rid of this denominator over here. So times that by 6.7, multiply this by 6.7, right? That cancels, and we're left with sine theta equals, now put this whole expression into your calculator. So we've got sine 86 degrees, 11 minutes, close brackets, over, so using the fraction button, 8.3 times 6.7 equals. Okay, so that gives me, gives me 0.805 dot. And then you're going to keep that whole expression in your calculator. Theta will be the inverse sine of all of this, 805 dot. So that's going to give you, so I'm going to go shift, press the inverse sine button, then press the answer key. So shift, inverse sine, answer, close bracket, and you should get 53.65 degrees. Now press the degrees, minutes, seconds button again. You get 53 degrees, 39 minutes. Okay. Rightio. Now, one thing you've got to be aware of, there is a special case that you need to consider, obtuse angle triangles and the sine rule. Now have a look at this. Clearly from the diagram, you can see that theta is obtuse. Now, we're going to find an unknown angle, so we write down our formula, we do the substitution, we get sine theta by itself, then work out theta on the calculator to be 40 degrees. But this angle here, 40 degrees, is acute. And clearly from the picture, you can see that theta is obtuse, right? So if you know the angle's obtuse, then you subtract your calculator answer from 180 degrees. That should be a degree symbol there, okay? So in this case, the proper answer is theta is 140. Your calculator will always give you an acute answer, okay? So if you know the angle is obtuse, this is for the sine rule only, by the way. The cosine rule will always give you the correct angle if it's acute or obtuse. But for the sine rule, the calculator will only give you the acute answer. So if you know the angle's obtuse, subtract from 180 to get the correct answer, okay? Now, why does your calculator give you an acute angle? Well, it turns out sine theta is positive if theta is obtuse or acute. Your calculator is programmed to choose the acute option, okay, by default. And in the next chapter, we're going to look at why that occurs. So have a go at this question by yourself. So there's your angle. Pause the video if you like. So sine A over A, because we're finding an angle, this is the sine rule we write down, sine B over B. Now sine theta is our unknown angle. The side opposite that is 12. And then other angle is 28 degrees. So we have sine 28 degrees here, divided by the side opposite that is 8. Okay, and then we're going to times by 12, and then times by 12. Okay, cross that out. Sine theta is equal to, let's work it out. So you're going to have sine 28 degrees over 8 times by 12. So you're going to get 0.704. 0.704 dot. So theta is equal to the inverse sine 0.04 dot, which equals, so shift sine, press the answer button, equals. So that's going to give, say, to the nearest degree, so I'll just round it straight away. To the nearest degree, you're going to get 45 degrees approximately, okay? Now, clearly from the picture, so what I'm going to say is, but theta is obtuse, okay? So therefore, theta equals 180 degrees minus 45 degrees, which equals 135 degrees. So your final answer is 135 degrees. Okay, and that is it for today's lesson.